All right, welcome back from break. And now we shall continue on to another example. And this one should be a little more in your wheelhouse. We're going to be talking about the Ohio School District report cards. So this is from the 2014-2015 school year. I'm looking at the third grade reading proficiency rate. And I like 2014-2015 because it's a couple of years before the third grade reading guarantee went into effect, which means that the third grade reading test really, proficiency level was still pretty meaningful in terms of understanding kids' achievement in districts. So here's what I have. I'm going to be predicting the percentage of kids who are proficient in third grade reading, and I'm going to predict it from the size of the district's third grade sample, like the number of kids in third grade in that district. And I'm going to also predict it from whether the district is getting an F, is failing, has received an F on the report card. And here I have some descriptive statistics about the number of third graders. You'll see I have 600 different districts in Ohio. The mean is 189. My range is from 3 third grade students all the way up to over 3,000 in a district. We have 386 of our school districts received an F on their report card. That's 63% of our sample. So now that's some basic statistics of what's going on. So here is the output of our additive model. The additive model is just does size of the school, size of the district, and whether the district gets an F, do those predict third grade reading proficiency percentages? So here's our sums of squared error table with our between subjects effects. Our dependent variable here, again, is the percentage at or above proficient. Oh, it looks like this is the 15-16 school year, not 14-15. Still the same applies. So to give you variable names here, you'll see I have NG3, which is the number of kids in grade 3. F is whether they got an F on the report card. So what do you see here? Does size, the number of kids in grade 3, does that contribute to our model fit? Folks at home, give me a yes, it does, or no, it does not. I got one yes vote. Anybody else? One more yes vote? I got 2 yes votes, 4 yes votes. Woohoo! Yes. I got secret yes votes. Yes, and you know that because number in grade 3 has a significant F test. What about whether the district received an F? Yes, it also is contributing to our model fit, reducing our error. Thank you. Now here are our parameter estimates. So let's look at interpreting the intercept here. It has done the same thing again, where having an F is given, you have a 1 if you've been given an F, which has been given a 0 within our model. So it aligns with what we talked about with cars and trucks. So the first one's easy. When size is 0, which 3 is pretty close to 0, so I think that's pretty close to within our range of observed data. When size is 0 and whether they got an F is what? We're going to interpret the intercept. That they did get an F. So schools that were receiving an F on their report card and have 0 kids, 0 third graders-ish, 56% of those are passing. That's how we interpret this. And now, going to try to interpret the size of the district, or the F. If I'm holding size of a district constant, the difference between a school district that has an F and a school district that doesn't have an F is what? The difference between a school district that does have an F and a school district that does not have an F . 18-ish. So a school district that does not have an F is getting 18 percentage points higher on their third graders passing the achievement test. Does this make more sense than cars and trucks? No, not more sense than cars and trucks? Same, different? We'll keep going. Maybe it'll make more sense. Oh, I just did that one. Interpreting 18, that's the difference between a failing school district and a non-failing school district in percentage points of kids passing third grade reading guarantee. Third grade reading test, sorry. So this is just our regular multiple regression output in an additive model. Next, I want to go through it for the interactive model. But before I do, I want to get, if anybody has questions about this data set, these coefficients, and how this is working. Because next you have a quiz. Now do you change your mind? Now do you have more questions? Okay, next we have a quiz. Let's do it. We have an interactive model next. I have changed the question. Does the relation between size of third grade and percentage of students who are proficient on third grade reading depend on whether the district received a failing score? So here is my blank equation. My y-hat for third grade reading proficiency percentage for a particular district is equal to my intercept plus the slope times whether they got an F plus the slope times the number of third graders plus my interaction times my whether they got an F times number of third graders. That's my regression equation, my linear equation here for relating my variables, allowing them to change and interact. Okay, here is the output, and the quiz is available to you on Carmen. So I'm going to give you quite a bit of time to do this quiz. More than my normal amount of time, but I'll monitor you. So I'm going to give you 12 minutes to work on this quiz. Once you've started. It is called Interaction Introduction Quiz. Yes, thank you for telling me which one. It's in the module. Okay, so let's go through the quiz. Right here we have the question breakdown. In looking at whether the model fits the data well, most of you got this question correct. I'm pulling that information from this overall F-test that has to do with the degrees of freedom associated with the differences between our full model and our restricted model. Wait, am I sharing? Yes, I'm sharing and recording. It just stops. I get it. Okay, sorry. So that's where this 130 comes from. It's pulling it from this model up here. Next we have, does the number of third graders in the district contribute significantly to the variance explained? And the answer is no, but you'll see that I typed it incorrectly. We're pulling from this box, the F box 0.509. So I'm not too concerned about those of you who got this incorrect because it's likely due to this error of mine. I will fix that. Next, in the regression equation, oh, cool. I've never tried this fill in the blanks. Was this good? Was this, you like that? Better than trying to pick between? Got a couple of yeses? Great. Okay, it looks like all of you got this right. Awesome. Most of you got this right, so have a look at these different blanks and you can see. Oh, cool. Tells you differences for each blank. So I pulled these directly from this coefficients table down here. Next, we have expected percentage of proficient third graders in a failing school with 0 third graders. So because they've coded F failing 1 as 0, that means that this is, yes, failing is the intercept. So this here is our 57.172 as the intercept. And now this one, 2 schools with 0 third graders. What's the expected difference between a school that received an F and a school that did not receive an F? I'm looking for the difference here. This here is the intercept, 57.172, so that's not about a difference between anything. This is an expected outcome. Here, I think that I tricked some of you because I said having 0 third graders. So you're used to that being, when I talk about 0, usually I'm talking about the intercept. But in this case, I'm talking about one of the predictors, because remember, like that graph showed, we always need to be interpreting things at whatever the 0 point is, which is why this one's correct there. Move this over here. No. Oh gosh. Relation between third grade size and expected proficiency depend on whether the school received an F. Now, I'm not surprised that a few of you got this wrong, because this, I've only really interpreted this a couple of times. But that is the coefficient. It's testing for the significance of the coefficient of the interaction, which is this guy right here, which I can't point at. There, this guy. And the significance of this interaction is, it is statistically significant. P-value equals 0.001. Okay, these were very tricky. In order to answer these, you had to fill these numbers into the regression equation in order to get the correct answer. This I was allowing for some rounding, is why I went here. So if you got something else here, I think if you plug all these numbers in, you should get 48, round 48. So that's using the regression equation to plug those numbers in. And then last, this is the same thing, but this one's even trickier, because do you remember how I did all of that math with the Excel spreadsheet? And you have to multiply both of your main effects and the interaction effect in order to get the closest nearest whole number. Okay, do you all want to talk about these? Do you want me to walk through these equations and we'll do the math? Or ask other questions? I have 1 thumbs up for math so far. Y'all just don't want to make any decisions, and I don't blame you. You know, I'm tired of making decisions too. This is kind of unfair because I did the math in order to do the questions. So they're already here. Here I have the intercept. This is B0, B1, B2, B12. I've pulled the intercept here, 57. This is the slope. That's weird. This slope is -0.009 also. I promise I didn't fake that. That's just actually the case. Both of those are real data sets. That's really strange. Okay, for whether it's a failing school, I've got 15. And for the interaction, it's 0.014. And so what I did here, what's the best way to do the math? How would you like me to do this? Let's just plug it all in. Y equals, I'm just going to type it, 57.172 minus, you could do plus a negative or a minus, 0.009 times the number of students in grade 3 plus 15.395 times whether it's a failing school plus 0.14. Oh, thank you. 0.14 times what the size of the school is times whether they're in a failing school. Okay, there's my math. So let's next, go through this and say, what was my first one? A school has 1,000 third grade students. So that is going to be, I'm going to plug this in as 1,000. And I'm going to plug this in as 1,000. Does that make sense so far? Okay, then as a next step, what am I asking? If it does have an F. So if it does have an F, right? I don't know why my cursor won't show you there. F is 1 is where it was 0. Remember? F is 1 is where it was 0. So that means I'm going to fill in. That's so annoying. I'm going to fill in Hold on. Please hold your horses. It won't let me share that screen if... Just down to the last second. What's it gonna be? Oh my God. Okay, sorry about that. Now, we're going to plug in a 0 here for F, and where'd my other F go? And a 0 here for F. Okay, that much make sense? So now we're going to solve it. Woo! And now, to do the other one, the only difference there is that we're going to plug in this situation, we're going to plug in 1 for F, which means now this term is going to be involved, And we're going to plug in a 1 for f here, which means this term is also going to be involved. So now that becomes the final equation for this question of, I have a school with 1,000 third grade students. The expected percentage of passing students for a school if it does not have an F. Is this, which then, because I've already done all the math and I phrase this with an equal sign, I can hit return and I get 77. Does that clarify things? Was it like math errors or like didn't even know which numbers to pick? Math errors. Numbers to pick. A little of column A, a little from column B. Okay. Tell me what of this that I have gone through that you don't have access to. So these, like, do you want this slide, this little guy right here that I just did? I'll upload this to the thing, what's it called? Carmen. Anything else I should upload to Carmen? Yes, the new graphs. I will put those in Carmen too. Should we do graphs right now? Should we graph this? Do you want to? Okay, here's the thing. We're done. I had some other things to show you, but I feel like I'm reading the room. We're a little toasted today, so we're going to be done. So I will upload this to the Carmen site, so you'll have access to it. And